And number 20 on this worksheet on 2.8. Is there a number whose natural log is equal to 5 more than the opposite of its cube? Okay, let's make an equation out of that. Is there a number whose natural log, so we're talking about the natural log of some number out there, x, and we want to know, is the natural log of that number equal to, here we go, 5 more than the opposite of its cube. So with 5 more than, that's going to be a plus. We really should put the 5 at the end, and the opposite of its cube would be the opposite of that number there to the third power. You might have written that right side as 5 minus x cubed. Might actually be cleaner, but I want to be consistent with how we handle less than and more than. So whatever, either way is fine. Okay, so there's the equation. Next step is to get a function out of this. So f of x equals, and we're going to move all of our terms to one side or the other. Really doesn't matter which side you do that on. I'm going to move everything over to the left, guys. I'm going to move this here and this here. So I'm going to make this function x cubed, it's now positive, minus 5, and then a plus the natural log of x. And of course, we want to know, is that function ever equal to 0? Okay, so that's where we're at. I just showed you a trick on number 19. I don't know if you guys watched that video or not. Sometimes a quick sketch of the graph here might give you a clue on where to go, and I think that could be helpful here. The left side of this equation was the natural log of x, which looks a little something like that. The right side of this equation, negative x cubed plus 5, is a function that starts up here at 5, and then it does up on the left, and it's going to go down on the right. So I'm pretty darn certain there is a solution here, and it looks like it's going to be in the first quadrant there somewhere if I had to guess. That tells me, guys, that when I go to make my tables here, I probably want to start looking to the right of 0. So I'll go ahead, go x and f of x, and I think we'll start by putting in a 0 there. Although actually, I take it back, we can't do that. If you try to put a 0 into this function, you're going to run into a problem right there because the natural log of 0 is undefined. So what you might want to do to get around that, I'm not sure if this is going to be relevant or not, I may need to come back and put in a really small number like 0.1. Or that might not even be relevant. Let me put in a 1 and then a 2, maybe a 3 if I need it. So I'm going to hold this guy off in my back pocket. Let me just do 1 and 2 and 3 right now. Now the natural log of some of these numbers is going to be too complicated to do by hand, so I take it back. The first one with 1 we probably could do. 1 cubed is 1, minus 5 is negative 4. The natural log of 1 right there, guys, is 0. So that ends up equaling a negative 4, but the 2 and the 3, yeah, I would need my calculator for that. So, all right, I put it off as long as I could, but here goes. All right, guys, so I'm going to go back to my main page right here, and I am going to redefine this. Let's get a clean page to start off right here. We'll clear our history out. Okay, and here we go, everybody. We are going to, here we go, define, got it, f1 of x, all right, to equal, and now here we go. The function we came up with right here was x to the third power. I'll double check that in just a second. And then it was a minus 5, and then a plus, I better double check this, plus natural log of x. I'm looking at this function right here. Yeah, x cubed minus 5 plus natural log of x. X cubed minus 5 plus, here we go, natural log of x. Okay, got it. And just to kind of show you that I wasn't crazy here, or to show myself that, f1 of 0 we thought, oops, should be undefined. And let's make sure that it is. Good. And we already came up with f1 of 1. I believe we got that to equal negative 4, if I'm not mistaken. Okay, we're in good shape. Now here's what we needed the calculator for, guys. We needed f1 of 2. And I'm going to go ahead and do Control Enter and get that number as a decimal. All right, sweet. That one's positive right there. So right there, guys, in the first two values that I checked, I see the sign change. f1 of 1 was negative 4, but f1 of 2 is positive what? 3.693. So let me write that one down. 3.693. And right there, everybody, that is what we were looking for. So answering the question right here, this is a yes. There is a number out there whose natural log is equal to 5 more than its opposite, and that number exists between the two consecutive integers of 1 and 2. And now we'd use the bisection method here to cut that down a little bit more. So let's see what that would look like. Making this table just a little bit bigger and easier to follow. I'm just going to rewrite part of this right now. At 1, we got -4. And at 2, oh, I forgot what it was exactly, positive 3.693. Now it's time to start bisecting that a little bit. Halfway between 1 and 2, obviously, is 1.5. And let's see what happens there. So F1 of, here we go, 1.5 is going to get us a negative value, negative 1.219. Okay, so I'll write that down, even though its value isn't super important right there. Got it. And now what does that tell me? Don't bother looking here. That's just negative to negative. That's no help. We're now looking on the bottom half. So let's bisect this bottom range and go with a 1.75 and see what that gets us. So here we go. F1 of 1.75 is a positive value. Looks like it's 0.919. All right, so we'll put that here, 0.919. Now, no sign change here. Now we're looking at this spot right here. So we'll bisect the interval from 1.5 to 1.75. That's a 1.625. And let's see what that does for us last time here. So F1 of 1.625, got it, is a negative result, negative 0.223. Okay, negative 0.223. So where are we looking? Not here. That's not where the sign change is. It's right there where we go from negative to positive, and we've got to equal 0 for some c value in between. So the interval here on which this solution exists is from negative 1.625 to 1.75. And the directions just said to whittle this thing down to an interval length of 1/8, which is 0.125. That's good enough. If they wanted us to, we could go further, but I think that does a pretty good job of giving us the point of how the bisection method works. So that's problem 20.